All right, welcome back, everyone. Welcome to round 4 of Brain Fried, where we're talking about blockchain, all the interesting technology that's happening, all the innovation, and we are on the second part of round 2. So we're on round 4, but we're on round 2 of going through the Near protocol. And the reason why we're going through the Near protocol is because the graph this is the first non-EVM chain that the graph is indexing. And so we want to learn a little bit more about Near. We just dive deeper into the rabbit hole and we discover new projects, we discover new technology, and we see if it's interesting to us. We try to see what's unique about it and if it has large use case, small use case, the good, the bad, the ugly, everything. So in the last video, we left off. Oh, I just want to preface this with one more thing. This is not financial advice. This is strictly educational. I'm learning as you're learning. We're all learning this new technology together. I just researched this stuff on my own time because I enjoy it. It's Saturday night right now, and I'm here learning this stuff. This is what I do for fun, I guess, and I enjoy sharing this information with you. So in the future, though, if you do have any recommendations, just drop some comments. I'll read them since there's not that many of them. So I'll definitely read them and take them into consideration. So with that said, we're diving back into Near protocol. No headphones today, so I'm hoping that you can hear it fine. I was having audio issues, so hopefully we're good to go this time. There's a few things that we have to catch up on, like always, because things are moving very fast. So I'm going to speed through the rest of this documentation, which is not something I would normally like to do, but in this case, there's really one thing that we have to touch on Near protocol that's very unique, and I would say it's the meat of Near. Um, it kind of sets it apart is what we're looking for, right? So the technology that sets it apart, and that's what we're going to try to focus on. So I'm just going to skim through the rest of the document, and then we're going to circle back to sharding, which is something that I mentioned in the last video. And I was like, oh, what's sharding? But I kind of just overlooked it and didn't really question it too much. But it turns out sharding is kind of well, how do you say it? I want to say the bee's knees, but it's kind of the secret sauce, I guess you could say, of Near's implementation. And it's not a novel concept, but it is different from what other chains are doing and how they view the future of Web3 and how they view the blockchain usage. So we're going to spend most of the time on that. The other thing is YouTube is limiting my videos to 15 minutes for whatever reason. Maybe it's not doesn't get as much attention or something. So most likely we'll have to split this video again into another section. But we'll just keep talking. I'll most likely pause at 15 minutes and then maybe do the introduction again just for people, since it's going to be a separate video. But other than that, no more prefacing. Let's just dive into it. So transaction fees, there's nothing new, nothing unique that I want to dive into on this part. Excuse me, my throat's feeling better, but it still kind of gets hoarse pretty quick, so I got the water. The only thing that is interesting, well, not the only thing, but one of the main things that I saw that was interesting is the storage aspect of it. They kind of reference some similarities or differences, the problems, I guess, with chains like Bitcoin and Ethereum. And they say the mispriced storage, that they misprice storage by only allocating reward to miners who mine specific transactions instead of future miners who will need to continue storing data while they're mining. So it boils down to data storage basically. And what Near does to kind of account for data storage on chain is they allocate accounts with certain Near, basically translates to a certain amount of storage that you're allocated, which is perfectly fine. Storage costs money. It should cost, if storage costs money to developers and on the hardware aspect, it should cost money all the way up the chain, right? That's sustainability right there. So here is just a table of the relationship between storage and Near that is staked or locked, and you can look closer at that if you're interested. Validated rewards, it's going to have different percentages, maybe a few different kinks from other blockchains, but the idea is similar. You get rewarded for validating. I'm not going to dive into this. Let's see. I don't think I found anything interesting in this. Selection, that's validator selection, I believe. Number of seats, validator seats. Yeah, this is not super exciting. Delegation, protocol, treasury, contract awards. Now this is something that is kind of interesting, and I just skimmed through this, but let's just read this example. So for example, if Alice sent a transaction to smart contract A with some near fee, and contract A doesn't call any other contract, then it will receive 30% it will receive a reward of that much, which is 30% of the original amount. On the other hand, if contract A is using contract B for 50% of its processing or functionality, then A and B will split the contract reward. So that's interesting. This is the first time that I've seen this type of implementation with smart contracts. I don't know. I mean, I haven't seen that before, so I don't know if that's a normal thing or not. But basically, the smart contract that's deployed on chain is being rewarded for the work that it's doing. It sounds like, um, which is almost similar to saying that the subgraph, the most popular subgraph, how many times it's being queried, it's being rewarded for processing those queries. So it's the, you're getting paid for doing work, basically. So that's an interesting concept. That's the first time I'm seeing it, that I've actually read about it implemented on a blockchain. So I don't know if that's novel, to be honest, but it is a cool idea. If this is not known, smart contract is just section of code, functions, whatever that run on the blockchain. Okay, account name auction. This is something that is becoming more popular with blockchains. They're using human readable account names instead of like the hash and all this. So I think it does help in terms of a developer perspective, but I don't think it's it's not unheard of. Like I think Ethereum has a separate like ENS service. They do like a name translation or something. I don't know. And then so feel free to come back to this. If you want to dive deeper into it, I can link to it, or the link is I don't know if you can see the URL. Sometimes it cuts the thing. So I'll post. I mean, I'll post the near documentation URL. The other thing that I was planning on going through that we're gonna kind of skip over is this very detailed near architecture. Excuse me, architecture, design, implementation. All the specifications. Everything how it works. It seems a little bit not super exciting to me unless we want to dive into just maybe cross contract calls. That could be interesting if we have questions about that. The other thing, what were we looking at before where I said, oh, the memory, the memory allocation, we could dive into that maybe to see how that works. That's going to be, if someone requests it in the comments, we'll definitely go back to it. But there's something, so the sharding thing is kind of the meat of where I'm going with this. I'm going to come back to this. So I did a test project where I just launched something on their testnet, on the near testnet, and I was just playing around with it a little bit. Just kind of like a hello world example project, and it was fairly easy. I might come back and do a little front end work and maybe try to connect it to another layer 2 chain that I'm looking at on another project. So I might end up using Near just for the decentralized application that I'm going to build. We'll see. So, okay, back to sharding. So here's an interesting discussion that I want to just play through. We're at 11 minutes just about, so we'll see how far we get, and then I'll probably pause it. So this is a discussion between two CEOs with Solana and Near. I believe Near CEO's name is Alex, and the Solana's CEO's name is Alantonia. Sorry, forgive me on that. Their discussion is basically saying sharding versus not sharding and the benefits, the pros and cons of it. Oh, shoot. Let me back up.
How
Okay,
many shards?
so what is sharding, right? Like we kind of just glossed over it, and I just Googled what is sharding or like sharding, and I learned a little bit about it. And here's a Google image that just expresses it. It's very simple. It's a very simple concept. Instead of having your database, so if we have this, if we think of the blockchain as kind of like a database or like ledger or whatever, Sharding just kind of breaks up that database into sections or into shards and splits the data and stores them separately. So it looks like the first three on this one were spread into this shard, and then the bottom three might have been or bottom two, sorry, were spread into this shard. And what would end up happening is basically this consolidated table or this blockchain would have an extra layer now between the user query and the user query. I don't know if that's the right word. Yeah, kind of. Basically, the user interaction and the information. So now we have to have routing, right? Because we don't know which shard the data exists on. So we have to have a mapping. This increases complexity, and it's not an easy problem to solve. And then, but the argument is that now this information, and then, hold on, sorry, I'm kind of bouncing back and forth. There's a lot of information to digest, but so you shard it, and now you have everything distributed, and now you lose that redundancy, that safety net, where if one node fails, you have the data backed up on another node, and things can rehydrate or reload itself when it comes back online, things like that. But now if you lose a node, you kind of have permanent loss of data, right? So that's another problem that this introduces. I don't even know the solution to that, but there is definitely solutions to that that much smarter people than me have come up with. So what's the advantage of it? Well, there's this, and what they argue about, the CEOs argue about, is scalability, really. Like, are you gaining scalability or are you gaining decentralization? And I would argue you're gaining both, but the argument really is that you're not really gaining scalability because these shards can now exist on kind of smaller machines, and the capacity of the shard is limited by the machine. And so, um, I don't know. I mean, it's definitely a reasonable debate to have, I believe. So I want to listen to what they have to say, the CEOs have to say, a few points to touch on. And we're about 30 minutes, 13 minutes, 30. So I'm going to kind of give a closeout here. We're going to continue in the next video with this sharding versus unsharding in Near versus Solana, the CEO discussion. Just point out a few points. All right, so I'll see you then.